Russia's Launchpad 31 just suffered catastrophic damage during the MS-28 Soyuz launch. The support tower collapsed, the maintenance cabin was completely destroyed, and this is their only operational, crew-capable pad for ISS missions. Without it, Russia has lost independent access to space for at least a year, maybe two. What happens to the cosmonauts who need to rotate home? Who will keep the ISS supplied with critical cargo and fresh crews? There's only one spacecraft capable of filling this gap right now. Welcome to Space Update 24 Hours. Let's dive right in. The Soyuz MS-28 mission started like any other routine flight to the ISS. At 4:27 a.m. Eastern Time, the rocket lifted off from Baikonur Cosmodrome in Kazakhstan, carrying 2 Russian cosmonauts and 1 American astronaut. The ascent was flawless. The spacecraft entered its planned trajectory perfectly, and within hours, the crew was on their way to dock with the station. But back on the ground, something had gone terribly wrong. Within minutes of liftoff, reports started flooding in from Baikonur. Launchpad 31, the primary pad for Soyuz crew missions, was destroyed. The support tower had collapsed. The maintenance cabin beneath the rocket deck was obliterated, blown into a nearby trench and reduced to unrecognizable debris. What was supposed to be a routine launch had just turned into Russia's worst launchpad disaster in 60 years. How could this happen to one of the most experienced space programs in history? The answer lies in the brutal physics of the Soyuz launch system. Unlike American rockets that lift off almost immediately after ignition, the Soyuz holds its engines at full thrust on the pad for several seconds before releasing. This design characteristic, standard for Russian systems, channels immense heat, pressure, and acoustic energy directly into the structures below. The 4 RD-107A engines produce a combined 754,000 pounds of thrust, and all that force gets concentrated into a relatively confined space beneath the rocket. Russian launch pads don't use the wide flame trenches common at American facilities. Instead, much of that exhaust energy is directed downward through a narrow channel, with the largest exit point positioned directly above the maintenance cabin. For decades, this system worked. But infrastructure doesn't last forever, especially when subjected to repeated exposure to superheated exhaust traveling at supersonic speeds. The footage from the aftermath tells the story. The maintenance cabin, which before launch looked like a clean, organized workspace where technicians could access the rocket, was completely gone. Scattered debris, twisted metal, a trench filled with wreckage. The 4 hinged support arms that normally cradle the rocket appeared damaged as well, swept by the blast wave during those critical seconds of engine ignition. This wasn't just equipment failure. This was a catastrophic structural collapse that took out Russia's only operational crew-capable pad for ISS missions. Roscosmos issued a brief statement on Telegram confirming the crew was safe and the mission was successful. They acknowledged the launch pad damage and said repairs would begin after a full evaluation. But anyone familiar with launch infrastructure knows the truth. Repairs of this magnitude don't happen quickly. We're looking at a year minimum, possibly 2, before Launchpad 31 is operational again. What does that mean for Russia's space program? Without this pad, Russia has lost its independent access to the ISS. They can't launch replacement crews. They can't send cargo resupply missions on their own. And the astronauts currently aboard the station, including Russian cosmonauts, are now dependent on another nation's spacecraft to rotate home when their missions end. The implications extend beyond national pride. The ISS requires constant support to remain operational. Crews need to rotate every 6 months to prevent physical and mental strain from extended stays in microgravity. The station needs regular deliveries of food, water, scientific equipment, spare parts, and critical supplies. Miss too many of those windows, and you start compromising the safety and effectiveness of the entire orbital outpost. Russia now faces a choice they've been trying to avoid for years. They need help, and there's only one entity capable of providing it on short notice: SpaceX. The Dragon spacecraft has become the backbone of ISS operations over the past several years. It's reliable, flexible, and proven. Dragon has carried cargo and crew consistently, adapted to changing mission requirements, and served as the backup solution whenever other spacecraft encountered problems. NASA depends on it, international partners depend on it, and now Russia may have no choice but to depend on it too. This creates a fascinating dynamic. Politically, the relationship between the United States and Russia has been strained for years. Sanctions, geopolitical tensions, and competing interests have driven a wedge between the two nations. But the ISS exists in a different realm. It's a shared international project, built on collaboration and mutual dependence. Both sides have astronauts aboard. Both sides have scientific experiments running. Both sides benefit from keeping the station operational. If Russia formally requests assistance through official channels, SpaceX could easily add extra Dragon flights to cover crew rotations and cargo deliveries until Launchpad 31 is restored. Elon Musk has never been shy about stepping into gaps when launch capacity is needed. Dragon has the manifest flexibility, and NASA has the coordination experience to make it work seamlessly. But there's a deeper question here. Will Russia accept this help, or will national pride push them to find another solution? They do have alternatives, though none are ideal. Russia could potentially redirect some missions to other launch facilities, but those pads aren't currently configured for crewed Soyuz flights. Modifications would take time and money, resources that are already stretched thin. They could accelerate repairs at Launchpad 31, but rushing construction on critical infrastructure comes with its own risks. Or they could simply reduce their ISS presence temporarily and rely on international partners to maintain operations. Each option has consequences. Each option requires compromise. The broader lesson here is about infrastructure and sustainability. Russia's space program has an incredible legacy. They put the first human in space. They built the foundation of the ISS. They've launched more crewed missions than any other nation. But legacy alone doesn't maintain launch pads. The Soyuz system, for all its reliability, is built on decades-old designs and aging infrastructure. The pad that collapsed this week has been in service for over 40 years, subjected to repeated launches, extreme temperatures, and corrosive exhausts. Eventually, everything wears out. Meanwhile, SpaceX represents a different philosophy: rapid iteration, reusable hardware, and modern materials designed to withstand hundreds of launches. Their infrastructure at Cape Canaveral and Vandenberg gets rebuilt, upgraded, and reinforced continuously. They learn from every launch, adapt quickly, and invest heavily in long-term sustainability. This disaster at Baikonur highlights the gap between those two approaches. Russia built a system that worked brilliantly for decades, but didn't evolve fast enough to meet modern demands. SpaceX built a system designed from the ground up for the challenges of sustained, high-cadence spaceflight. Now Russia must decide how to move forward. Do they modernize aggressively, adopting new materials, better pad designs, and fail-safe redundancies? Do they continue with incremental improvements to proven systems, accepting the limitations that come with older technology? Or do they embrace international collaboration more fully, acknowledging that space exploration in the 21st century requires shared resources and mutual support? The ISS won't wait for those answers. Crews need to rotate, supplies need to flow, science needs to continue. And for the immediate future, that means Dragon will likely carry more of the load than ever before. SpaceX may not have planned to become Russia's lifeline in space, but circumstances have a way of creating unexpected partnerships. This launchpad disaster proves that even the most experienced space programs aren't immune to infrastructure failure. Russia built their space legacy on decades of reliable launches, but one catastrophic collapse has exposed the vulnerability of relying on aging systems without adequate redundancy. Now they face a reality they've spent years trying to avoid, depending on an American company to maintain their ISS presence. SpaceX didn't set out to become Russia's backup plan, but Dragon is now the only spacecraft capable of filling this gap quickly. The coming months will reveal whether national pride gives way to practical cooperation, or whether Russia will scramble to find alternatives that may not exist. What happens next could reshape international space collaboration for years to come. Will this disaster accelerate Russia's modernization efforts? Will it force deeper partnerships between former rivals? Or will it mark the beginning of a reduced Russian presence in low Earth orbit? The ISS doesn't care about politics. It needs crews, supplies, and constant support to survive. One collapsed Launchpad just changed the balance of power in space operations, and we're watching history unfold in real time. What do you think Russia should do? Accept SpaceX's help or find another way forward? Drop your thoughts in the comments below. If you found this analysis valuable, hit that like button and share this video with anyone interested in space news. And don't forget to subscribe to Space Update 24 Hours and turn on notifications so you never miss critical updates like this. Thanks for watching and keep looking up.